Hello, my name is Carly McAvoy, and we're doing the lesson to go along with multiplication, and you can have your multiplication practice sheet out and follow along with that and try to work the problems as we go through. The most effective way is for you to pause the video and try the problems and then come back and see if you've done them correctly. The first thing I ask you to do when you're working in this sheet is to label parts of a problem. We've already done addition before and subtraction, and now we're doing the terminology that goes along with multiplication. So let's write down just briefly again the terminology for addition. If I have something like 12 plus 7 equals 19, I know that 12 is an addend, as well as the 7. When you're adding both parts the same name, the answer to an addition problem is a sum. The addition sign itself, that's an operator or an operation sign. And we also have this, which if I wrote in a different format would just be the equal sign. And so it's not an equal sign exactly, but it is an equivalent symbol. It suggests that these things are equal to each other. So we would want you to be able to name all of those parts. When you're talking about a subtraction problem, something like 20 minus 3 equals 17, we have the same thing as far as the operator goes. This is your operator. I'm just going to call it OP. And this is your equivalent symbol. That's just like we saw up there. And the parts, though, are named differently. The answer to a subtraction problem is difference. The problem that the number you're subtracting from is called the minuend. And the answer is the subtrahend. And those, if you don't remember those, you can go back to the subtraction video, which I think is lesson 3, and look those words up again. Then we have the new thing today, which is the multiplication. So if I have 5 times 7, then I would say that 5 is a factor. Factor is a part of the numbers that are going into the multiplication problem, and this is also a factor. The answer to a multiplication problem is called a product. So that's the product. Similarly to the other ones, we have the operator and we have the equivalent symbol. However, I want to tell you that there's more than these ways to write a multiplication problem, and I want to show you all the ways, and we're going to be using different formats. When you say 5 times 7 equals 35, those multiplication facts, by the way, it's nice to have those memorized. It depends on your instructor. You'll have to see what their call is, whether you can use a multiplication sheet or not. But you can get hold of a multiplication sheet and have those facts in front of you as you work through your problems. But it is good to know them so that you don't spend a lot of time where every time you see 5 times 7, what is that, what is that? You don't have it in your head. 5 times 7 can be written this way also. When you put a parentheses around a part of it, that's another way to say multiplication. And I could put a parentheses around the first one and not the second one. That also says multiplication. So parentheses are a way to show that. I could also do this, 5 times 7. That's another way to write it. I could also do 5 times 7 like that. That's another way to write multiplication. So we can use the dot, we can use parentheses in a number of different ways, or we could write it with the old X. as you go further and further into math, you will use the x less and less. People don't like that because we start to look at that as the letter x and use it as a what we call a variable later. So you'll start to see less of that, but you'll still see it in this class. Let me tell you about the parentheses for a second. What a parentheses is, it's something called a grouping symbol. A grouping symbol is a parentheses or a bracket or braces. They all have the same function mathematically. It's just a grouping symbol. Sometimes we use parentheses, sometimes a bracket, sometimes braces, but we always mean the same thing. So up there where I was writing all the different ways to write your multiplication, I could also do 5 times 7 that way, or 5 times 7 that way. Or I could do 5 in parentheses and 7 in brackets. That also means multiply. You can interchange those whenever you want. I could put them in braces. I could say 5 times 7 inside parentheses, inside braces with the dot. I mean, when I group things together with the different symbols, it doesn't matter which one you use. So you might ask, then why have all those different grouping symbols? Why not just have the parentheses? What's the point? Well, here's the point. Let me show you. Sorry, this is a little slower than I thought it would be. Let me show you why we would want to have more than one different type of grouping symbol. And I know we're getting away from multiplication a little bit here, but it makes sense to talk about it now because you use the grouping symbols for multiplication. Let's say that I had a problem like this, 5 plus 7. And then I said, oh, but I want you to multiply that whole thing by 2. Then I would say, okay, times that by 2. And just by writing the 2 there, that means that you're going to multiply. And then I say, oh, but really I want to take that whole thing and I want to subtract 3. So then I go like this. I'll take this whole thing and I'll subtract 3. But then I want to take that whole thing and I want to add 4. And if you're, whoops, that was plus 4. If I do that, it starts to get really confusing with the parentheses. Which one goes to which? What does that mean? But let me rewrite that problem a little differently. So I have 5 plus 7, and I decide, oh yeah, I want to multiply that by 2. Typically, we're going to use the parentheses first because they're the easiest ones to write with. But then I want to take that whole thing and I want to subtract 3. So I put a bracket around it this time. Now I can definitely see parentheses and I can see brackets. Now if I want to add 4, I could go back to parentheses, or I can put a braces here, and then this problem actually is easier to read because I can read the parentheses, the brackets, the braces, and so it makes things more readable. So grouping symbols are up there for a reason, and we use them for different reasons, but typically you'll see us using parentheses for our grouping symbols. Unless we have more than one set, we start using different sets. So that's just a little side definition for you. So what I'm going to ask you to do is to find the product of some numbers. And you have to know the basic multiplication facts in order to do that. And I'm not going to do the whole table, but you can easily make a table for yourself. So let's say I want to go up to the 6s. I would make a chart, and you could do this on paper for yourself, and you might want to use a calculator to make the chart. Even if your teacher says that you can't use a calculator in class, there's no reason why you can't go home and use a calculator and make up a chart like this. Some instructors will allow you to use a chart where they wouldn't allow you to use a calculator. So you can make your own chart, but you can go online and Google it. Google is your friend. You can find whatever you want on there, and you could find a multiplication table for yourself. Just Google multiplication table and you'll see. So what I'm going to do is look at this way. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 1 times 5 is 5. And 1 times 6 is 6. Most everybody knows your 1 tables, but that's how that goes. And then it goes the same way down the side. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4, 1 times 5 is 5, 1 times 6 is 6. So you're going to see that the numbers are the same as you go along the edge there. Then I'm going to go through and do the 2's. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12. And I'm going to go down this way. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12. And you're going to want to make your chart maybe 11 by 11, and then but it's going to be that you're going to fill in less and less every time you go. 3's, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. And look what's happening when you're doing these. It's 3 more each time. So you could be adding, right? 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 3 is 18. Because multiplication is a shorthand way to do addition. Every multiplication problem you ever did, you could do it as addition, but it could take you a long time as addition. Multiplication is a lot shorter, nicer way to get things done. Remember, you're going to go down the same way, so 3 times 4 is 12, because that's what it was over here, and then 15, and then 18. This would be a nice quick reference. I don't know why I made my 8 with 3 loops, but we'll go back and change that. 18. Now I'm going to say 4 times 4 is 16. Remember what's happening with the 4? I'm adding 4 each time. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, plus 4 is 24, and then I'd have the same numbers going down this way. And then 5's. Notice how 5's always end in a 5 or a 0. 5, 10, 15, 20, 25, 30. There's a lot of patterns that you can see in here, and that's going to be 30. And then 6 times 6 is the only other one we'd have to do to fill this in to get 36. Have a chart nearby, work on memorizing them, or have a calculator to do some of these small parts, but you still need to show your work. But for these single digit numbers, if you have those memorized, it helps a lot. Okay, that's how to make a chart. Okay, so let's see the first kind of product I asked you to do. I am going to change the numbers a little bit so that you have something to practice. But the first one says multiply something like, this is actually 4 on your sheet, something like 12 times 8. It shows you with the dot. And so then to do the problem, you would actually rewrite it in this format. That's the easiest way to do it. Then you multiply 8 times 2, that's 16, and carry the 1. Just like with addition, you're carrying, you're leaving the 1s, you're carrying the 10s. And then 8 times 1 is 8, plus 1 makes 9. And so the product is 96. That's the answer to a multiplication problem, is a product. 8 and 12 are called what? Factors. So we have the factors that make the product. The next problem looks something like this, 74 times 63. Bigger numbers, double digits, it just requires that you multiply more than once. Notice up here when we're multiplying, we just did the 8 times the 2 and then the 8 times the 1. We're going to start off doing that with the 3. And so I'm going to do 3 times 4 is 12. And then carry the 1. 3 times 7 is 21, plus 1 more makes 22. Now here's what you have to do in multiplication. You probably remember this, but in case you don't, the next row I'm actually multiplying by 6, but it's really 60 because it's in the tens place. So I'm going to put that 0 in right there, and that's going to shove everything over. Now I just multiply like it's 6, even though really it was 60. That's why I put the 0 there. 4 times 6 is 24, carry the 2, and 6 times 7 is 42, plus 2 is 44. That's the kind of math you may not be able to do in your head. It may take a little bit longer. Use your multiplication chart or do it slower, but you need to be able to get those single digit multiplications like 6 times 7 down. Then I'm ready to add that up. 2, 6, 4. So 4,662 would be my product. Oops, product. And my factors would be up here. This is just my work, but that's not a factor. That's not what's going into the problem. The factors are the numbers that you start off with. Okay, we have number 6, looks something like 138 times 41. I'm going to again multiply by the 1 first. 1 times 8, 1 times 3, and 1 times 1. Because I'm multiplying by a 10, 4 is a 10, so I'm going to put a 0 to scoot that over. Some people might have learned just to leave a blank. That's okay, but sometimes when you leave a blank, you don't get things lined up nicely. So I always put the 0 to keep things be lined up. 8 times 4 is 32. I'm going to put the 2 and carry the 3. 3 times 4 is 12, plus 3 is 15. Carry the 1. And 4 times 1 is 4, plus 1 is 5. And then I add those up. 8, 5, 6, 5. Hopefully by now you could label the product and the factors. And it looks like this. The product is your answer, and the factors are the numbers that you started off with, 138 and 41. It looks like I'm pointing to the X. The X is the operator. That's the multiplication symbol. I actually meant to point to the 41 there, in just case anybody comes in and says, oh, she's confusing me. It looks like that. The 41 is your factor, and the 138 is your factor, and the product is down there, the answer. The third problem on that, I don't think I have space to do that, so I'm going to clear this. It's number 7, the fourth problem, I should say. The fourth problem looks like 832 times 247. Big numbers, they're written in the parentheses. Remember, parentheses is a way to indicate multiplication. But in order to do the problem, I'm going to rewrite it this way. You don't have to necessarily line numbers up when you multiply. That's kind of nice. But you do want to line the work that you do gets lined up nicely, so you can add down your columns. You want to do that. But when you write it up there, it doesn't have to be, but it sort of naturally happens. 7 times 2 is 14. Carry the 1. 7 times 3 is 21, plus 1 is 22. Carry the 2. 7 times 8 is 56, plus 2 more is 58. Remember, the best way to work this, pause the video, try the problem, and come back. If you just sit and watch me, it's not going to be all that helpful. But you can also then try your practice sheet afterwards. Take it in and have your teacher look it over and see if you're getting those right. Also, if you go out and buy a calculator, not an expensive calculator, no one needs to go buy a graphing calculator and pay $80, $150, whatever. That's ridiculous. You could get for this class, you could get a calculator at the dollar store for $1 and check your work. But the best one, if you're going to go out and get one anyway, would be a TI 30XS. That would last you all the way through all the math classes you'd have to take up through if you took even probability and statistics in college. But it's a good calculator to have around the house. Sometimes you want to check things around the house. It's nice to have a calculator laying around. The TI 30XS you can get for less than $15. It will last you 15 years or more. It's a great calculator without a lot of expense. What I would do is have one. I would try the problems, and then I would punch it into the calculator and see if you get it right. Okay, now I've done this first column, not finished. I got to go back. All I've done so far is multiplied by the 7. Sometimes it can get a little confusing when you have all these little marks up here. So it's okay if you want to erase the first bits and start over. Remember, now I'm going to multiply by 4, but it's really 40 because it's in the tens place, so I'm going to put a 0 in there. And now I'm going to say 4 times 2 is 8. 3 times 4 is 12. Put the 2 and carry the 1. 4 times 8 is 32, plus 1 is 33. Now I've got a third digit, so I'm going to have another place. The 2 is in the hundreds place. So in order to make it look like 100, I need to put those 2 zeros. And now I'm ready to multiply the 2. So every single time I add an additional 0, if I had another column, I'd have 3 zeros, then 4 zeros, and I keep pushing it over with the zeros. 2 times 2 is 4. 2 times 3 is 6. 2 times 8 is 16. Now that I've multiplied, this row was what I got when I multiplied by 7. This row I got when I multiplied by the 4, which was really 40. That's where the 0 comes from. And this one I got when I multiplied by the 2, which was really 200. That's why I have 2 zeros in there. So I multiplied that top number by 7, by 40, and by 200. That should look familiar to you when you talk about expanded notation and you have broken it out. This is really what's happening here. We're multiplying by that expanded notation. Adding straight down now. We have 4, 10, 15, 6 and 5 is 11, plus 3 is 14, plus 1 is 14. Nope, I don't think so. 8, 14, 15. Sorry about that. Slow down when you're doing this and take your time and make sure you get that addition right. This 5 and 3 is 8, plus 6 is 14, plus 1 is 15. So I'm going to have 15. 6 and 3 is 9, plus 1 is 10. 1 and 1 is 2. And so I have 205,504. And again, if you had a calculator, you could punch that in and see if you got it right. It's easy to make a mistake. I almost did. I can check my work this quickly on a calculator. 832 times 247 is 205,504. Now I feel confident that I fixed any mistakes that I might have made and I can move on. The next thing we're going to talk about is powers of 10. We're going to talk about exponents in detail in a few more lessons from now, but I just want to talk about them for a second here. A power of 10 is what we call 10, 100, 1,000, 10,000, 100,000. Notice what I'm doing here. Every time I'm just adding on one more 0. Those are what we call powers of 10. And multiplying by powers of 10 is really easy. And so it's nice to have some shortcuts, right? So if I have something like 27 times 10, all I have to do is put my 27 and add the number of zeros to the end that I had for my power of 10. I have 1 0, so 27 times 10 is 270. If I have 352 times 1,000, I would write my 352 and then 1, 2, 3 zeros, 1, 2, 3 zeros. That's all I have to do. When you multiply by a power of 10, all you have to do is add the trailing zeros. So it's really quick and easy to do that. But why do we call them powers of 10? I want to explain that to you. When I have 10 just standing there, that's the same as having 10, what we say, to the first power. There's just one 10. If I have 100, that looks like 10 times 10. Remember, the dot means times. 10 times 10 is 100, and that looks like 10. What power do you think? It's the second power because there's 2 zeros. That's a direct correlation, zeros and the power. When I have 1,000, I have 10 times 10 times 10. How many 10s do I have? I have 3 10s. And also, how many zeros do I have? 3 zeros, third power. When I have 10,000, that's the same as saying 10 times 10 times 10 times 10. 10 to what power? Well, we're just going in order here. That's 10 to the 4th. I have 1, 2, 3, 4 zeros, so it's 10 to the 4th power. If I go up to 100,000, same pattern occurs. I have 1, 2, 3, 4, 5 zeros, so that would be 10 to the 5th power. And if I wrote that out as multiplying by tens, it'd be 1, 2, 3, 4, 5. 10 multiplied times itself 5 times is 10 to the 5th power. So let's say I came down here and instead of writing 10 or 100 or 1,000 like I was doing, let's say I wrote it as a power. So let's say I had 49 times 10 to the 2nd power. How many zeros would I add on to the end of 49? Well, all you have to do is look at the power, and that tells you the number of zeros. So my answer would be 49 and then 2 zeros. It's easy as that. That's powers of 10. So let's say I had 721 times 10 to the 6th power. Well, I would have 721. That's kind of a hard one. And then how many zeros would I put on the end? 6, because I have 6 powers. So I'd have 1, 2, 3, 4, 5, 6. 721 million when I have times to the 6. So I'm going to ask you on your homework to do a couple of those powers of 10 problems. And remember, all you have to do is keep the number the same and then put on the correct number of zeros. So we'll talk about that more when we do decimal multiplication, because you're really just moving a decimal point, but when it's at the end you don't really ever see it, so it looks a little different. Okay, good. We're going to go on to do our word problems. And in the word problems section in this problem, actually let me call that up, the multiplication practice sheet. You can see that in the multiplication practice sheet I ask you to label a subtraction problem, an addition problem, and a multiplication problem, which we just did in this video. I'm going to ask you to multiply things that are in this format with the dot, in this format with the X, in this format with parentheses or grouping symbols, and then I'm going to ask you to do 3 of these problems where you're multiplying by a power of 10. Then we move on to word problems, but in the word problems I ask you circle the key word that tells you to use multiplication to solve, and then solve it. Well, multiplication is actually the hardest one sometimes to see the keywords. They're hidden more than any of the other ones. It's really obvious if they say increase, you're adding, or decrease, you're subtracting, or split up, you're dividing. But when you're saying multiplication, it's not always obvious. But in this problem, let's read it. For the 30 days of September, the Garcia family averaged 107 gallons of water per day. What was the total water usage for the month of September? Well, what I know about this problem is that they're asking me total. And I know that total is a word that you could use for addition. And they find the total of everybody's work or whatever. Well, total, remember addition is just another way to do multiplication, right? Addition, you'd have to add 107 30 times. You could find that. But for multiplication, because it's a repeating addition, we can use multiplication. So even though it kind of feels like an addition word, it also can work for multiplication. So total. That one went away. I don't know why. Let's read the next one. Charlotte paid a $25 parking fine 12 times during her 2 years of working downtown. How much did she pay in parking fines? She did this thing 12 times. Times is a word that means multiplication. Just like total can mean multiplication, it could also, whoops, I circled 12 instead of times. Times is the one, because it means that it's repeated over and over and over. When you have something being repeated or multiple times, then you know it's a multiplication problem. On number 13, it says John bought 10 shares of stock at a cost of $54 per stock. After 2 years, or 2 months, the value of the stock tripled. Key word. And the following year, the value of the stock doubled again. What was the value of his stock after it had tripled and doubled? There's a couple of things going on here, so but I want to just first point out the key words. Key words here are tripled and doubled. Those are multiplication keywords. If something triples, that means times 3. If it doubles, that means times 2. So I know that I'm going to have to multiply times 3 and multiply times 2. And we'll get to those problems in a minute. Let's look at number 14. When Adolfo works on his lawn, he spends 45 minutes mowing and 10 minutes leaf blowing his driveway. If he did this yard work 15 times throughout the summer, how many minutes did he spend on his yard work? And that's where we're going to get times again. He did it 15 times, so he did this thing over and over and over again until he had done it for 15 times. I'm going to turn this off so I can use the smartboard, and so in order for you to see the word problems, you need to have those. So hopefully you've printed those off, or you have them on your computer, or somehow you're looking at them, so when I read them again, you'll be able to follow along. We're going to start with number 11. For the 30 days of September, the Garcia family averaged 107 gallons of water per day. What was the total water usage for the month of September? The total usage, the word total was our key. We're going to do something repeatedly, over and over and over, 107 gallons repeatedly. So I'm going to multiply 107, this is number 11, 107 gallons repeatedly. And here's a little trick. When I write times 30, instead of writing it underneath there, I'm just going to write it over to the side. And then I'm going to drop it straight down. Now I can just multiply. 3 times 7 is 21. 3 times 0 is 0, plus 2 is 2. 3 times 1 is 3. So that's 3,210 gallons of water in a month. What if I hadn't shifted that over? What does it look like? Well, if I didn't shift it over, I would do this. 0 times 7 is 0. 0 times 0 is 0. 0 times 1 is 0. That's the value, no value on that row. Then I would say multiplying by 3, however, the 3 is actually a tens place, so it's a 30, so then I put my 0 down. 3 times 7 is 21. 0 plus 2 is 2, and 1 times 3 is 3. Now when I add that together, I get the same answer. So it's nice to not have to do a row of zeros. If you have a 0, just put it off to the end, drop it straight down, and then multiply by 3. If you don't use that shortcut, if you do the second way, no problem, you'll get the same answer. I'm just trying to save you from writing rows and rows of 0. Just drop them straight down. It's a nice little shortcut. It's nice to use units. So my final answer, 3,210 gallons. That's the final answer. I would like you to use units. I didn't put on there that you have to put units on to get credit. Ask your instructor if they are going to require units. If, different people have different ideas about that. So we'll leave that up to your instructor. I'm going to put units on it because I think it's a good idea to do it. Okay, number 12, recall, said Charlotte paid $25 parking fine 12 times during her 2 years of working downtown. How much did she pay in parking fines? So she paid $25, and she did that 12 times. She didn't learn her lesson about parking. So 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. I didn't just drop down a 0 here because 12 doesn't have a 0 in it. I'm stuck with actually doing the multiplication. I'm multiplying by the 1, which is actually a 10, so I'm going to put a 0 there. 1 times 5 is 5, and 1 times 2 is 2. And add straight down, and you get 300. So that means that Charlotte paid $300 in fines over the 2 years that she worked downtown. Okay, let's look at number 13. It's got multiple parts. First of all, number 13 says that John bought 10 shares of stock at a cost of $54 per stock. So the first thing you want to do is figure out what the cost of the stock was originally. So we had 54 of those, and we're multiplying by 10, power of 10. So what would that be? Well, I would just put the 54 and add a 0 to the end. So the value of the stock when he started was $540. Then it says, after 2 months, it tripled. When you say something triples, that means it's timesing by 3. So if you have one baby, it's a baby. If you have triplets, you have 3, right? It's 3 times as many. So 540 times 3. We multiply by 3. 3 is our word that means tripled. When I say tripled, I mean times 3. 3 times 0 is 0. 3 times 4 is 12, so carry the 1. 3 times 5 is 15, plus 1 is 16. After it tripled, it had a value of $1,620. Not bad. But then it says the next year it doubled again. So now we're going to take 1,620 from when it tripled, and we're going to multiply that times 2. 2 is the key word is the number we get when we say doubled. If something doubles, you're going to multiply it times 2. 2 times 0 is 0. 2 times 2 is 4. 2 times 6 is 12. 1 times 2 is 2, plus 1 that I just carried is 3. 3,240. I originally bought the stock, he did, whoever it was, John, he paid $540 for that stock. It tripled, then it was worth $1,620. That doubled, which means that the cost or the value of his stock after it tripled and doubled is $3,240. So nice little profit for John. Okay, the last word problem. Remember, where am I getting these word problems? I'm getting them from printing them off from my instructor. Either hands them out to you, your instructor hands them out to you, or your instructor has them posted online so you can print them off. And then you follow along with the lecture from those so that you have those too. The last word problem says, when Adolfo works on his lawn, he spends 45 minutes mowing and 10 minutes leaf blowing his driveway. So he did this yard work 15 times. That word times is our key word that we know he did this repeatedly, so we can multiply. How many minutes did he spend on his yard work? Well, first of all, whenever he went out, he did 2 things, and so we need to figure out how much time he spent each time he went out. So it tells us in the problem that he spent 45 minutes mowing, and that he spent another 10 minutes blowing leaves. So first of all, every time he went out to work in the yard, he spent 55 minutes. That part you have to do. You have to add before you can multiply. So it's a 2-step problem. So now I know that he did 55 minutes worth of work each time, but now I also know that he did that 15 times. So I'm going to times that times 15. So this is a 2-step problem. First add the numbers together to get the total amount of time that he worked, and then times it by the number of times that he did the work. So 5 times 5 is 25. 5 times 5 is 25, plus 2 more is 27. Now I'm multiplying by 1, which is actually 10, because it's in the tens place, so I'm going to put a 0 down. 1 times 5 is 5. 1 times 5 is 5 again. Now add straight down. 5. 5 and 7 is 12. 5, 6, 7, 825. That's the total number of minutes that he spent doing yard work that summer for those 2 for mowing and leaf blowing anyway. 825 minutes total. And I put minutes on there because I want people to know when I'm finished, I'm not talking about lawns, or I'm not talking about leaf blowers, I'm talking about minutes. I want to give a unit to that number so that it makes sense. What is 825? It's the minutes he spent working. Okay, the last part asks you to find the product, and they wrote the problems in a different format. So for number 15, I'm going to change it a little bit, but this is how it looks, something like this. It has something like 205 and then 62. And it asks you to write those in standard notation and find the product. 205 looks like this. 62 looks like that. And the product means to multiply. So we would just multiply those together. But first we had to write them, given the written description, write them in standard form and then multiply. 2 times 5 is 10. There's nothing up here, so it's just going to be 10. 2 times 2 is 4. Multiplying by 60 looks like 6, but we put a 0 to scoot it over. 6 times 5 is 30. This is 0 plus 3, so it'll just be 30. And then 2 times 6 is 12. Adding straight down, we get 0, 1, 7, 2, 1. And so I get 12,710. Again, what I could do is after I write the numbers down, I could do the problem and then use my calculator to check. What your calculator isn't going to check for you is, did you write these numbers correctly? Is 62 really 62? Is 205 really 205? That's what you want to make sure you have down. That's why your instructor's there to look over your work and say, well, you didn't mess up on the multiplication, but you did write the numbers down incorrectly maybe, or maybe you wrote the numbers correctly, but you messed up the multiplication. It's okay to make mistakes. Everybody make mistakes when they do math. I worked this out ahead of time, I practiced it, but I could still make a mistake on here. Even though I feel confident in my math skills, I still make mistakes because that's how it goes. You can't get hung up on, I want to do this perfectly the first time. What you want to get hung up on is, I want to do this until I understand it, until I feel confident that I can do it. But you're not going to get to a point where I'm going to do this and I'm never going to make another mistake when I multiply. Math teachers make mistakes all the time, and we're very confident in our skills, right? So don't get too hard on yourself. You have to realize that you make mistakes. Sometimes you're driving to the store that you've been to 20 times and you take a wrong turn because you're spacing out or whatever. We all make mistakes on stuff that we're really good at, and we just have to go back and correct them. Okay, the last one on this is number 16, and it's asking you to write it in standard notation and then find the product. And you might have something like this: 10,000 plus 7,000 plus 20 plus 5, and then 3,000 plus 200 plus 90, let's say. Well, I'm going to rewrite these in standard notation. This is 10,000 and 7,000, that's 17,025. That's the first number. The second one is 3,290. There's no zero number there. So remember, when I have a zero, I wrote this down kind of like hurriedly. I want to find the product. When I have a zero tagging along the end there, I can just drop it straight down and not write a row after row after row of zeros. So what I can do is rewrite the whole problem if I want. Remember, I don't have to line things up when I multiply. I can rewrite it and just drop that zero straight down, and now I'm ready to multiply by 9. Or I can just write a 0 and go ahead and multiply by 9. So it doesn't matter if you didn't think to scoot it over to the edge, it's no big deal. 9 times 5 is 45. Again, have your multiplication table, work on those facts. 9 times 2 is 18, plus 4 is 22. 9 times 0 is 0, plus 2 is 2. 9 times 7 is 63. 1 times 9 is 9, plus 6 is 15. Now, remember that I already put 1 0 in there for the 9. Now I'm going to multiply it by 2, which is actually in the hundreds place, so I'm going to have 2 zeros for that one. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 0 is 0. 2 times 7 is 14. 1 times 2 is 2, plus 1 is 3. Now I'm going to multiply by 3,000. So that's going to have 1, 2, 3 zeros, because 1,000 has 3. And then you can look up here and see, oh yeah, I need to have 3 zeros there because I'm multiplying by 3,000. 3 times 5 is 15. 2 times 3 is 6, plus 1 is 7. 3 times 0 is 0. 3 times 7 is 21. Carry the 2. 1 times 3 is 3, plus 2 is 5. And now I'm going to add straight down. Notice how I really make an effort to line things up so that it's easier to finish up. Half the battle is just organization and neatness. That's 0, 5, 2, 12, 11, 10, 6, 5. So I think the answer is 56,012,250. If I wrote my numbers correctly, I can just go back into a calculator, 17,025 times 3,290, and hit enter. And I get 56,012,250. So I just checked my product and I had that correct. So I feel confident that I did that correct. We're at the end of our multiplication lesson, and there's a lot to practice. Remember, if you're doing this practice sheet and you don't feel like you've had enough practice, for one thing, you can go online and Google multiplication practice. Things will come up. You can also ask your instructor for worksheets, and they can give you things to practice so that you can get more multiplication practice. And remember, you're going to come into class after you've done the practice sheet and do an in-class sheet that looks like this with different numbers, so you do have that additional practice. You don't learn math by trying something once. You learn it by doing it over and over and over, just like anything else you're good at. You weren't good at it on day 1 or 2 or 12. You were good on it after you got much practice. So remember to practice as much as you can. What I want you to know for multiplication is I want you to know the terminology, factors and product, and the equivalent symbol and the operator. Those have not gone away. I want you to remember the different forms of multiplying. You can multiply with a dot, with parentheses, with the X. I want you to know how to multiply by powers of 10, which were the 10, 100, 1,000, and so forth. Also, I want you to be able to read a word problem and circle the word that might indicate to you that it's a multiplication problem, keywords. And we'll talk more about keywords when we do the word problem session. But they're in every single one of your lessons, word problems, because that's the good application. Some people say, well, I don't know why I have to learn math. When would I ever use it? And then you say, okay, well, here's how you might use it in an application, a word problem. And they say, oh, I hate word problems. Well, there you go. Word problems are how you might actually use it. So circle the keywords and try the word problems in here. And then at the end, I ask you to write a number in standard notation and find the product, which means to multiply. And both of those are written in parentheses, which indicates multiplication. So that's what I'd like you to be able to do for the multiplication sheet. And I hope you have a great day, and I'll see you next time. I think we're going to be talking about rounding and estimating.